Hello students, welcome back to my channel. Today we will start a new chapter known as continuity and differentiability of a function. So my first topic is continuity of a function at a particular point. Okay, so here's a function represented by this particular pink color line, and as you can see, at x equals to a, there is no breakage on this function. That means this function is continuous at x equals to a. But as we see that at x equals to b, there's a hole here. That means the function is breaking at this particular point at x equals to b. So here we say that this function is discontinuous at point b. So this is the simple meaning of continuity of a function. But every time we cannot check the graph of a function, so there should be some method to see whether the function is continuous or not at a particular point. A function is continuous at a point x equals to a if limiting value equals to functional value. Limiting value is simply the limit which we used to calculate in class 11. So a limit extending to a f of x. So this is called the limiting value. And what is functional value? We just put the value of x as a in place of x. So this is my functional value. So if these two values will be equal, if the limiting value and the functional value will be equal, then we say that the function is continuous at this point, that is x equals to a. Limit exists only if the left hand limit and the right hand limit are equal. So here, if I break this limit to its left hand limit and right hand limit, then this can be written as limit extends to a minus, which means that this is our left hand limit f of x, and our right hand limit we write as limit extends to a plus f of x. So this is my left hand limit and this is my right hand limit, and if left hand limit and right hand limit are equal, then we say that the limit exists. So that is, a function is continuous at x equals to a if left hand limit equals to right hand limit equals to functional value, or simply you can say that the limiting value and function value should be equal. So now let us check the continuity of this function, that is fx equals to x cube. So we will check this function is continuous or not at x equals to 0. So for that, I recommend you to make a number line where you can write the critical point, that is x equals to 0 here. So now as you can see that we have to check the limiting value and the functional value, and since the function is fx equals to x cube, so that means this function is same everywhere. That means on the right hand side of 0, the function is x cube only, and on the left hand side of 0 also the function will be fx equals to x cube, and at this particular point also at x equals to 0 the function is x cube only. That means this function is same on the whole real number line. So if the function is same on the left hand side of 0 and the right hand side of the 0, then we simply calculate the limiting value. We will not calculate left hand limit and right hand limit separately, because since the functions are same. So here limiting value, that is limit extends to the point is 0, f of x will be equal to limit extends to 0, my function fx is x cube. So here it will be, let us put the value of x as 0, then it will be 0 cube, which will be equal to 0. Now the functional value, that is f of a. So here the value of a is 0, that means f of 0 can be written as 0 cube, which is also 0. So here what I found is that the limiting value is also 0 and the functional value is also 0. That means the limiting value and functional value are equal. That means this function is continuous at x equals to 0. Since limiting value and the functional value are equal, that means the function fx is continuous where at x equals to 0. Let us check the continuity of this function fx at x equals to 0. So first let me draw a number line and let me mark the critical point, that is 0 here. When the value of x is less than or equal to 0, that time the value of fx is 3x minus 2. So on this side, that is left hand side of 0, fx equals to 3x minus 2. And on the right hand side, you can see that when x is greater than 0, the function fx is x plus 1. So here the function fx is x plus 1, and at this particular point at x equals to 0, we will write the function as 3x minus 2, because when x equals to 0 also the function is 3x minus 2. Now in this case we will calculate the left hand limit and right hand limit separately, since as we approach 0 from the left hand side my function is 3x minus 2, and as we approach 0 from the right hand side my function is x plus 1. So in this type of question we have to calculate left hand limit separately and right hand limit separately. So here left hand limit, that is x tends to 0 minus f of x, will be equal to limit x tends to 0 minus the value of fx I'll be writing will be 3x minus 2, since we are approaching 0 from the left hand side and the function is 3x minus 2 this time. So now let us put the value of x as 0, then it will be 3 times 0 minus 2. So this is equal to minus 2. So my left hand limit is minus 2. Now next we will be calculating the right hand limit, that is limit x tends to 0 plus f of x equals to limit x tends to 0 plus, now this time the function fx is x plus 1, since we are approaching 0 from the right hand side and that time the function is x plus 1. So here it will be limit x tends to 0, so it will be 0 plus 1 and this will be equal to 1. Now since it is clear that the left hand limit is minus 2 and the right hand limit is 1, that means left hand limit and right hand limit are not coming equal, that means limiting value does not exist. And if the limiting value does not exist, then the function is not continuous at all. Since left hand limit does not equals to right hand limit, therefore fx is not continuous at x equals to 0. So here this time I didn't calculate the functional value because the limit does not exist for this function. Next question is, check the continuity of the function fx equals to modulus of sin x over x if x is not 0 and the value of fx is 1 when x equals to 0. So we have to check the continuity of this function at which point at x equals to 0. So my critical point is 0. Here first we will break this modulus of sin x into two parts. So it will be minus sin x when sin x is less than 0, which means x is less than 0, and this modulus of sin x will be plus sin of x if sin x is greater than 0. See, I'm not writing equals to because at x equals to 0 we have the functional value as 1. So sin x is greater than 0 means the value of x is greater than 0. If I rewrite the function, then fx will be minus sin x by x when x is less than 0, and the function is 1 when x equals to 0, and the function will be sin x over x if x is greater than 0. Now since my critical point is 0, so first let me draw a number line and let me mark a critical point as 0. Now as you can see that when x is less than 0, the function is minus sin x over x. So here it will be fx equals to minus sin x over x, and on the positive side of 0 the function is sin x over x, and at the point 0 the function fx equals to 1, which was given in question. Now since here also the function are different on the left hand side and right hand side of 0, so that's why we have to calculate left hand limit and right hand limit separately. So here first we will calculate the left hand limit, that is limit x tending to 0 from the left hand side of fx will be equal to limit x tends to 0 minus the function is minus sin x by x. So it will be minus limit x tends to 0 sine x over x. Now as you know that from class 11 we have a one formula that limit x tends to 0 sine x over x is 1. So here it will be minus 1. So my left hand limit is minus 1. Now we will calculate the right hand limit, that is limit x tends to 0 plus f of x will be equal to limit x tends to 0 plus. So as we approach 0 from the right hand side, the function is positive sine x over x, that is sine x over x. So here it was minus minus. So here it will be 1 because limit x tends to 0 sine x over x is 1. And here also, as I have noticed that the left hand limit is minus 1 and the right hand limit is 1. So the left hand limit and right hand limit are not equal. That means limiting value does not exist, and hence the function is not continuous at x equals to 0. We will look one more question on this video. So here the function is modulus of x plus 3 when the value of x is less than or equal to minus 3. That means we see that this x is already negative because this x is less than or equal to minus 3. That means this is already on the negative side, and on the negative side the value of modulus x will be minus x. That means if I rewrite this function, then here my function will be fx equals to minus x plus 3 when x is less than or equal to minus 3, and the function is minus 2x when if the function is greater than minus 3. And we have to check the continuity of this function at x equals to minus 3. And on the left hand side of minus 3, my function is minus x plus 3, and on the right hand side of minus 3, my function is minus 2x. And on the point x equals to minus 3, my function is minus x plus 3, because when x equals to minus 3, then the function is minus x plus 3 only. Now since again here also we have to calculate the left hand limit and the right hand limit separately. So my left hand limit will be extending to minus 3 minus f of x equals to limit x tends to minus 3 minus the function fx is minus x plus 3, and if I put the value of x as minus 3, then it will be minus of minus 3 plus 3, and that will be 6. Now let us check the right hand limit. Then here it will be limit x tends to minus 3 plus the function on the right hand side of minus 3 is minus 2x. So now let us put the value of x as minus 3, then it will be minus 2 into minus 3, and the right hand limit is also 6. Now in this question my left hand limit and right hand limit is 6. That means the limiting value exists and the limiting value is simply 6. Now we will check the functional value, and the functional value will be f of minus 3. Now at x equals to minus 3, my function is minus x plus 3, so we will use this particular function, that is minus x plus 3. And since we put the value of x as minus 3, then it will be minus of minus 3 plus 3, so it will be 3 plus 3 equals to 6. I hope you understood how we found the functional value. Since my function fx was minus x plus 3 at x equals to minus 3, my function was minus x plus 3. That's why f of x equals to minus x plus 3. That means f of minus 3 will be minus of minus 3 plus 3, which will be eventually 6. Now as you notice that my left hand limit is 6, right hand limit is 6, and my functional value is also 6. That means the left hand limit and right hand limit and the functional values, all three are equal. That means my function is continuous at x equals to minus 3. So this much in this video. So we will be looking more questions on the next video. Thank you.